I've already told you a little bit about how they are related to the exponential. So I want to look at a graph and actually see what that relationship is. When we graph exponentials, what did we do to draw those graphs? So if I say graph 2 to the x power, what did we do? Made a table. What values did we plug in? We put those in for the exponent. Remember those graphs always had a horizontal asymptote, right? It was just the x-axis, and it was either increasing or decreasing from there. So let's draw that graph. So 2 to the x. We did our t-chart. What is 2 to the negative 1 power? What's 2 to the 0? And 2 to the first? Negative 1, 1/2. 0, 1. 1, 2. And remember, then it was just a nice curve. It approached the axis, didn't actually hit it. What's the domain of that? What is the range? All right. Now let's talk about the log. So if I said y equals log base 2 of x, now we're trying to graph that. A little less obvious, maybe, what to plug in, but we could rewrite this as an exponential, couldn't we? So I've told you, you start with the base. So I start with my 2, go across the equal sign. So 2 to the y power equals x. This is just an exponential, isn't it? When we graph exponentials, we put in negative 1, 0, and 1 for the exponent. Which variable is the exponent? So I'm putting in negative 1, 0, and 1 for my y. 2 to the negative 1. 2 to the 0. 2 to the first. Do these points look familiar? What happened to them? It flipped. What's it called when x and y flip? Inverses. The log and the exponential are inverses. So if I plot these, 1/2, negative 1, 1, 0, 2, 1. So when I graph this, my y can be anything, but we know if I take a 2 to a power, I'm never going to get a negative. So this one ends up with a vertical asymptote. The y-axis is our asymptote. What's the domain of that then? And the range? So just like we always talked about, when you have inverses, the domain of the function equals the range of the inverse. The range of the function equals the domain of the inverse. So these are inverses. When we graph our logs, we are going to just change it to exponential form like that, and then we'll be plugging in the negative 1, 0, and 1. So it's very similar to graphing an exponential. We just have that step at the beginning where we have to rewrite it. We'll do it just like we did with the exponentials. If I have anything different on it, we will always do the parent function and then transformations after that. On a log, since it has a vertical asymptote, what kind of transformation would move your asymptote? Would up and down change your asymptote?
No.
Left and right will end up moving that asymptote. And so if your asymptote gets moved, you have to make sure and draw that in. All right. Let's graph this one. F of x equals log base 1/3 of x. F of x is the same thing as what variable? So if you prefer to write y, you can. To graph it, I want you to change it to exponential. So this is really the big thing that we have to be able to do from these two sections. To write it as an exponential, the base of the exponential and the base of the log are the same. So I start with my 1/3. Go across the equal sign. So it's 1/3 to the y power equals x. So on to get my graph, I do my t-chart and I'm putting in -1, bless you, 0 and 1 for the y because it's in the exponent. What's 1/3 to the -1 power? 1/3 to the 0. And 1/3 to the first. -1, 1, 0, 3rd 1. So we know this should be curved, and we just have a vertical asymptote here. So exponentials always have a horizontal asymptote, logs have a vertical asymptote. What questions do you guys have on this? And we can see this is either, the last one was increasing because the base was bigger than 1. This one was falling because our base was smaller than 1. All right, let's try graphing these. Actually, I'm going to change this one to base 3 as well. All right, to get these graphs, I want to do a parent function and a transformation. My parent function is just our basic y equals log base something of x. So in this case, for these, it would be log base 3 of x. That will be my parent function. So that's what I'm going to graph first, and then figure out my transformations from there. How do I write that as an exponential? Good. 3 to the y power equals x. So the t-chart for my parent function, we do -1, 0, and 1 for the y. 3 to the -1, 3 to the first, or sorry, 3 to the 0, and then 3 to the first is 3. So I plot my parent function. What are my transformations? What does this +2 do to my graph? Left 2. I don't know why I said that. So we will move each point left 2, and what else gets moved? make sure if you move your asymptote that you are drawing it in. And that you make sure when you do your graph that doesn't cross over that line. Domain and range. What is the domain of this? The parent function was, and we don't hit the -2, so it gets a parenthesis. What's the range? Okay, so same parent function. What does the +2 do here? Does that move my asymptote? Okay. So, looks like this. Still have an asymptote at the y-axis. What's the domain? And the range? So far, so good? Alright, I want to do maybe 2 more graphs, and then we'll move on from there. So we're always starting with our parent function. This one I had changed the base of 3, so it was the same parent function we had done on part A. Let's do one with a different parent function. I think I'm going to change one of these, and then I want you guys to try them both. So parent function for the first one, y equals log base 1/3 of x. What is that in exponential form? So if you do your t-chart, y is the exponent, so we put in -1, 0, and 1 for the y. So 1/3 to the -1 is 3, 1/3 to the 0 is 1, 1/3 to the first is 3. Whoops, 1/3. All right, so if we plot those points, so 3, -1, 1, 0, 1/3, 1. This is our parent function. What does the -2 do? So that would move my vertical asymptote to +2. And then if I move each point over, it should look like this. Domain and the range is always -2. B, I changed that one. So our parent function is y equals log base 4 of x. Bless you. So 4 to the y equals x. Do your t-chart. 4 to the -1. 4 to the 0. 4 to the first. Okay. If I plot those, -1, 1, 0, 1. Okay. What does a negative on the x do? Over, if I'm taking my x and making it negative, it flips it over the y-axis. So, if I flip these points, it should look like this. What's my domain turn out to be then? And our range, still negative infinity to infinity. Is that okay? Last thing I want to talk about. Do we need more graphing problems? Okay. So the last piece we need is to talk about how can I find the domain without drawing the whole graph? Like, is there a way I could look at x minus 2 and know that my domain was 2 to infinity? How? And remember, we've been talking about with these logs, the argument always has to be positive. So we can find the domain just by saying the argument, so the thing inside the log has to be greater than 0. Okay, I don't care if there's anything else on the outside, if I'm multiplying, subtracting, adding, doesn't matter. I only care what's inside the parentheses. So that means the x minus 1 has to be greater than 0. Can't equal 0, strictly greater. So that means x has to be greater than 1. So how would I write that? On b. I just have log base 3 of x. So my argument, the thing I'm doing the log of, is just x. So that just has to be greater than 0. Okay, the minus 1 just moves my graph down. It doesn't change the domain. It's just 0 to infinity. All right. C and D are a little trickier. I wanted to give us some that we had to think about a little bit. This one, so we know the absolute value of x has to be greater than 0, right? If you wanted, you could even think about the absolute value function. What does it look like? A v. When is it greater than 0? Always, except when it's 0. The only time it's not bigger than 0 is when it is 0, right? So basically this one, it's bigger than 0 as long as you don't plug in a 0. So it's everywhere else. Anything smaller than 0, anything bigger than 0. The only thing we can't have is the 0 itself. All right, D. My argument has to be greater than 0. Okay, we can't just solve this like normal, adding over the 4 and square rooting. You can't square root over that. It does factor into x plus 2, x minus 2. Remember, we have solved these quadratic inequalities before. It's been a little bit. So the two things that make it equal 0 are 2 and negative 2. Or if you just think about the graph, this is a function we're familiar with. X squared is a parabola. What's a minus 4 do? When is this graph greater than 0? it's positive. So that's here and here, right? How would we write those intervals? Good. So most of the time, we're just going to have linear things like A and B where you can just solve them. But we could have some more complicated ones, and that's okay because we know some of those graphs, and we could think about the graphs to help us. All right, do you guys have any questions for me? Okay. There is a handout posted on Google Classroom.